In this video, we're going to look at two questions on gravitational forces. So, first of all, the question one says, Emmy walks into a lift with a set of bathroom scales. She stands on the scales, presses the button for the 30th floor, and starts a timer. As the lift begins to move, she notices that the reading on the scale varies with time, according to the equation below. So this equation is essentially when the elevator is moving up or the lift is moving up, the mass that is measured by the mass scale varies according to this equation. And for question A, write down an expression for the acceleration of the lift as a function of time. Okay, so first of all, it says to write down an expression for the acceleration. Now, for mass, how do we calculate mass? So let me simplify this equation first to see what we can extract from this equation. So mt is equal to, let's multiply out the bracket first. So this will be 60 minus, let's say it's 6 over 10 t squared. Now, there is actually one thing that we can derive out. So in this case, if t is equal to 0, if t is equal to 0, this means that the lift is at rest, because the lift is obviously accelerating from rest in this case. And so we will be able to know the actual mass of ME. This will be equal to 60 kg. So if she weighs 60 kg, then we might be able to extract something from this equation about the acceleration. So first of all, how do we calculate the mass? So F is equal to ma, so therefore the mass is essentially equal to force divided by acceleration. Now, if we actually apply this to this case, I don't think we can actually do something about this. So maybe we can do something about this part that is multiplied by the 60, because we know that 60 is the initial mass, or the actual mass of ME, and then this part changes it. And I think I know how to do it. So okay, so if we look at this part, let me write this equation again. There's something that we can derive about this. So first of all, if we consider an elevator, so an elevator, and it's moving upward, how do you calculate the force or the weight or the mass, the weight, let's say, acting downwards? So let's say there's a person over here. The weight acting downward is two things. First of all is the person's own weight, and then there's also another force which is caused by the acceleration of the elevator upwards. So essentially it's experiencing two forces downwards, and the other force is ma. And in this case, if we look at this, if we look at this equation, there's something similar. So if we time it by g, so let's say mt times g, then we will know that 60g is essentially just mg plus 6gt minus 0.6 gt squared. So then you will realize that this part is just ma. So we would know that acceleration, so this part is ma, so the acceleration will be this part divided by the mass to get acceleration. And so let's see, let me use the black pen again. This becomes divided by 60, so that's let's factor out the g, and then divide by 60, so that's t over 10 minus divided by 60. Yeah, oh yes, this essentially becomes the previous equation. This is essentially the acceleration. And this will be answer for question A. Now for question B, it's ask how fast is the lift moving after 10 seconds. And then from the answer in the previous question, we can derive an equation for the velocity. Velocity will be equal to the equation for acceleration times dt. So we have to use a bit of integration. Let me write the equation over here again. So it's g times t over 10 minus t squared over 10. So now we simply have to derive this, and yes, okay. And it says moving after 10 seconds. So if 10 seconds is 0 to 10, and then so we can factor out the g over here, and then the inside just becomes divided by 2, so that's 20 over 1 t squared minus, let's see, so that's divided by 3, so it's 1 over 300 t cubed, and it's 0 to 10. So this is equal to, we can ignore 0 because everything just becomes 0. And for 10, we can put in 10, so that's essentially 100 divided by 20. That is 5 minus 1000 divided by 30, 300, sorry, so that's 10 over 3. And then this is around 9.81 times 5 minus 10 over 3, which is equal to 16.35. And this will be equal to the speed of the elevator after 10 seconds. This is the answer to the second part. Now, for the third part, it says after the initial 10 seconds, the lift decelerates at a constant rate until it arrives at the 30th floor. So it decelerates at the constant rate. That is a very important piece of information. And given that the 30th floor is 100 meters above the ground, calculate the minimum value of the mass reading shown on the scales during this deceleration. So the minimum value of the mass reading shown on the scale during this deceleration occurs when the deceleration is at the minimum value. Well, if it decelerates at a constant rate, this means that the mass read will be constant during this period. So what we have to do is simply calculate the deceleration during this period. Okay, so let's see. It gave us the how tall is the 30th floor, which I don't think there's actually much use to it, because the lift decelerates at a constant rate. So what we know, what we want to solve is A, but we don't know the time, and we can calculate a distance, And we know the initial speed, we know the final speed. Okay, and then we can calculate acceleration. Cool. We can use this equation. V squared is equal to u squared plus 2as. Now, in this case, we need to calculate s. So for s, what we can do is do another derivative on the function for velocity. So and we'll get 1 over 60 t cubed minus 1 over 1200 t to the power of 4 from 0 to 10, and this is equal to 10, so that's 1000 over 60 minus that's 100 over 12, and this is equal to this times 100 over 12, and we can derive a value for this. 9.81 times divided by 12 times 100 gives us 81.75 meters. So now we will be able to know that the distance traveled during this period of deceleration, constant deceleration, is 18.25 meters. Now, and then we can put this into this equation. V squared is equal to 0, u squared is equal to 16.35, yes, squared, and then it's a deceleration, so it's a minus 2a times s, which is 18.25, and so therefore a is equal to 16.35 squared over 2 times 18.25, which is equal to squared over 2.2 times 18.25, and that is, let me see, 7.32, with 3 decimal places, 324. Okay, so now we know the acceleration. What we have to do is simply calculate the mass. And how do you calculate the mass? So it's rather simple. So see, mg, or mg is equal to mg minus ma as its deceleration. So initial mass 60g minus m times acceleration and this is equal to 60 times 9.81 minus 7.324 over 9.81, 9.81, and it gives us 15.2 kg, and this will be answer for the first question. Now, for the second question, it says a railway carriage for transporting liquids is carrying a viscous liquid and it is only half full. It's half full. The carriage is attached to an engine which pulls away with a constant acceleration, so that the fluid in the carriage forms a steady sloping surface. If the acceleration of the train is 0.84 meters per second squared, what is the angle of the liquid surface to the horizontal? Okay. What we can do first is visualize the system. So let me draw a diagram. It's a circle. Okay, square. And so it says it's half full and then it forms a sloping surface. Forms a sloping surface and constant acceleration pulls away. So in this case, let's say it's moving this way at 0.84 meters per second squared. And then, what else? The acceleration, what is the angle? So what we want to calculate is the angle to horizontal. So that is, say this is the horizontal, we want to calculate this angle. Okay, so this is a rather abstract question. We're only given the acceleration. But there is one very important piece of information, which is that forms a steady sloping surface. If it's steady, this means that this system is in equilibrium. Now, if we look at one particle of water, let's say the particle of water over here, and then we zoom in a very large circle over here. Now, not exactly water, yeah, it's liquid, some kind of liquid. And so, first of all, we assume that the carriage is moving towards the right, so in this case, it will be experiencing a force to the left, and to the left, and the force will be simply its mass times the acceleration. And apart from that, because it's a sloping surface, let's say we can basically assume that this water particle is on an inclined plane. And so if it's in the sloping surface, then we can say there's also a normal force. This normal force is going this way. And another aspect is that it's also experiencing a force downward, one of the most fundamental forces in nature, which is mg. And what we are given is that this system is in equilibrium. Now, how do we link this back into its angle? So first of all, we know that the angle that we need to calculate is simply this angle. There are several ways to do this. My idea is that we can break the vector into different forms. So we know that these two forces, they sum up to produce n. Now, in order to produce n in that direction, and it is perpendicular to the surface, the components of mg in this direction and the component of fma in this direction should cancel out each other in order to produce n in that direction. So simply we can set an equation for this. So first of all, for this vector, this will be equal to mg sine of theta, and this is equal to this vector. Now, how do you resolve for this vector? And then this is a right angle triangle. 90 minus theta. And these two are parallel, so therefore this is simply 90 minus theta, so therefore this is theta. Okay, so the other one will be 0.84 m times cosine of theta. And then we can cancel out the m's, and it becomes tan of theta is equal to 0.84 over g. So therefore theta is equal to gives us 4.9 degrees, and this will be answer for this question.